Ooh, I got Ed. Okay, Ed joined. So the link works. And Ed shows up on mine.
Sorry, let me mute.
we go. Okay. Sound now? I got bars now.
Oh, yeah.
Okay. Yeah. Okay. I think it's because I put Ed's screen up, and so it won. Sound now? Yeah. I got bars now.
Oh, yeah.
Okay. I think it's... Okay. So as I was saying, there's a setting in the logger to connect the SASL logger, which by default logs to only the IX console, which is why we don't see the output normally, so that you see it at all times. It'll appear as red text. And it'll actually say why each gen server shut down. It'll actually be logger output.
Okay.
So by default, it says it logs to the console, which I assume means IEX. Yeah. So when you're testing with mixed tests, you don't see that output. But it's happening all the time in the background, I guess. And if you touch the logger, then you can just see if you run mixed test and you see SASL output, you probably have a bad test, a test that's killing your supervision tree unnecessarily. If you did want to actually test that your supervision tree could get shut down, what you could do is there's a matcher in XUnit to actually capture the log output so that it would suppress that SASL output temporarily. The only caveat would be is you couldn't run asynchronous tests then. But if this happens to you, it will present as very weird errors if your supervision tree gets killed this high up. Because like I said, it'll be like that logger can't connect, or it'll say ports can't connect. There'll be very strange errors. And so if you just turn on stronger logging with SASL, you will be able to debug this faster. One thing I would say, if you're actually using RabbitMQ, the default example client code says that when a queue is deleted to kill the gen server that's connected to the queue, and that was what triggered this bug, was I was cleaning up between tests by deleting the queue. And so that killed the gen server cleanly. But as the book talks about, the default supervision restart strategy for stuff is a normal exit would still count as something that should be treated differently instead of transient. And so that would still trigger a cascading failure.
Oh.
So
I guess you can delete the queues with RabbitMQ, but I think how I had set it up originally was that we had it to auto-delete, like the queue is a temporary queue.
Exclusive or ephemeral or something like that? Yeah, this was the main one for a partner. What you're thinking of is the response queue, the one that like the server sends back on.
Oh.
I agree. That one we always keep ephemeral because that's the recommended way.
Right.
The why I did delete was because the clearing the queue didn't work because there was a race condition of the clear for the setup and test would actually happen after the server already attached because it's part of the supervision tree.
Oh.
So it's actually up and running before.
Oh, okay.
I ended up doing.
That's fun.
I ended up doing a clear after I realized that I didn't have to make my own test copy of the server because it was in the supervision tree already. But like forgetting that you have something in the supervision tree and you're going to test it with a fake copy is a problem because the supervision tree is kind of global, so you have to remember it's there.
Yeah.
So now we can move on to the actual text for this evening. So chapter 7 finally gets to how most of us would start a real project, which is using Mix to make a project. Up until this point, it was just small example files, but it's not how you start an actual project. And you just do that with Mix New. This would be the equivalent of bundle gem or gem new. So you get the default layout, and you also get all the OTP goodness because OTP isn't extra; it's not separate. So the project you make will be an application that can be used by other projects for dependency purposes. It'll have a top-level supervisor if you pass the soup flag. And by default, all the code goes in lib. Phoenix projects are different, mostly because they want the web folder to be auto-reloaded and the lib folder to be static library code. And also any supervisors where you wouldn't want them restarted, you want them to cleanly shut down and come up would sit in lib inside a Phoenix project also. Part of the naming convention, just like Linux assigned name and numbers or gem naming, you want the top level namespace you use to be the name of your hex package. You don't want to put modules outside of that namespace because, in theory, anyone else can claim them when they make a hex package of that name.
And what happens if two hex packages have the same name, same namespace?
Last one wins, I think. Yeah, last one would win because think about it. It's how when you reload code, the module gets completely replaced. There's no the modules aren't open; they just straight up replace each other.
Yeah. Okay.
So you would get a warning that the module is being reloaded, but that's it. I mean, it's very easy to miss the warnings when you compile.
True.
Because mix compile by default, the warnings appear, but it's not warnings as errors. There is an option to do that with the compiler, but it's not on by default. Additionally, just stylistically, we prefer one file has one module, but there's no enforcement of that like there would be in Java, say. And you'll even see sometimes the standard library, if I remember correctly, the enum.ex file actually has enumerable the the protocol and the enum module in one file. It's very large. If you ever look, the standard library is very large, but part of that has to do with it has so many doc tests, which is something I do recommend. All our code right now is being doc tested because then your documentation is right because XUnit tested it. Writing doc tests also means that you kind of check that your APIs are easy to explain, and that can point out that your API is maybe too complex or too hard to use in isolation, because you want to be able to unit test each thing and explain why you would want to run this specific function. And if it's too hard to get to the point where you can call that function in the doc test, that's a good sign that your API is wrong, that it's going to be hard to maintain. One thing that I think the new naming convention document in Elixir 1.2 points out, but wasn't pointed out previously, is that module names are camel case, and those become underscore separated in the file system, and any dot in the module name becomes a directory separator. But for people coming from other languages, they might not be aware of that convention.
Isn't that, I mean, that's a common Ruby convention, right?
Right, but we really shouldn't assume that everyone's coming from Ruby. I've had students before that they didn't know Ruby, didn't know that convention, and they just named it the same thing because why would the file system care? It supports upper and lowercase characters, like OS X does. It doesn't care. It's just case insensitive. So it's something to be aware of that we should point out to anyone we're teaching that might not be coming from a Ruby background. To run your mix project, the canonical way is to do IEX space dash capital S space mix, and the dash S is just the flag that says runs this thing as a script. So what it's actually doing is writing the console and then running mix as a script, and mix is doing the default task, which is launching your application. So it's the equivalent of mix run, but you don't have to say run because that's what mix means when you just say mix.
What is the difference between an EXS, the mechanics of the difference between an EXS file and an EX file? Like I know an EX file gets compiled to bytecode, right?
It just won't save to disk is the difference.
So it just on the fly compiles it to bytecode?
Always, yeah.
And then it doesn't generate any of those temporary files, right?
Yeah, it doesn't even have temporary files. It is completely in memory.
Like what?
Yeah.
Okay.
Swap files, I guess? Because in Vim, the tilde files would be swap files. So maybe that's what they're called? I don't know. Sasha himself has just put out an update for what should have changed in this book because of 1.2.
Oh, yeah.
But I'll emphasize it too that anytime he uses hashtick, Hashdict is now soft deprecated in 1.2 because 1.2 requires Erlang 18, and Erlang 18 made maps scale past 32 elements. So all the stuff with Hashdict where they had to fake a dictionary structure that could have millions of elements by hand now can just use the built-in maps. So anytime you see Hashdict, you can just replace it with straight maps.
Pretty nice. Kind of simplifies the learning curve a little bit.
I had people at my prior company who were like, well, when do I use Hashdict? When do I use dict? When do I use keywords? I could explain keywords as, well, you want multiple values. Or you care about positioning, which is why they're the default way to specify options to functions. So on page 185 in section 7.2.1, when they're implementing the cache, you'll see that they use hashdict.fetch. Hashdict is part of the dict protocol, and so it's still there for map.fetch. And fetch is nice because unlike Git or the access protocol, which is what the square brackets are called, it will tell you the difference between there's no key there and there's a key there, then the value happens to be nil, which can make a difference. So, for example, we're writing an API that uses JSON API, and they make a difference between there is no entry for that member, and the member actually has null in JSON API, which we turn to nil when you decode it using Poison. So you sometimes want to tell the difference, and so fetch, instead of returning nil when the key does not exist, it'll actually return error, and on there being a key, it'll say OK and the value. So you can very explicitly, using a case statement, tell the difference between no entry in the map and the entry has a nil value. So chapter 7, since it's talking about concurrent systems, starts to walk through, which I think is a real strength of this book, where it starts to show you how to find bottlenecks in your system. And the first bottleneck it finds is the cache, because in order for the cache to work, you have to try to populate the cache, and if you're populating the cache, it means it becomes a barrier as you just first populate it before you can read it in parallel. But it makes a very clear point that before worrying about optimizing, you should measure the actual performance of the cache. Because if you don't get me that high of a request rate, there's no reason to try the more complicated solutions. Another thing when switching to parallelism is to realize that the single process touching one resource, such as a cache, is how we do synchronization in the distributed parallel system of being. If you make it multiple processes, there's no way to have synchronized access to make sure you have ordering and to make sure you don't screw up stuff, except for certain guarantees that we'll cover later. Coming from a Python or Ruby background, I found it interesting that Erlang term to binary actually works for everything in the virtual machine. It's how the wire format works for distributed Erlang. It's how S works for debts on disk. Like, there is nothing you can't serialize. It'll just work because we can't make data types that aren't composed of pre-existing data types. So Erlang already knows how to convert everything into a wire protocol for us. So if you can avoid having to talk to other languages, it is way simpler to just talk distributed Erlang, because Erlang will do the term to binary for you, than for you have to come up with, like, I'm going to do JSON API, or I'm going to do REST, or I'm going to do SOAP. Like, you can just, Erlang talking to Erlang will just work, and you don't have to do special stuff for it. Another benefit is the distributed Erlang can monitor that the remote node went down when the remote monitoring that's built into the distribution system sees the node goes down, so you have to worry about, did my message get there?
Oh no.
Oh no.
That's probably means for some reason.
Well, you can actually sit in front of mine, because I'm not using the slides anymore.
It says it's on.
But you're right, I see that she's paused.
Wait, is that only latched on that one hotspot?
I could.
Oh, wait, it just says Ed joined.
Okay, it's gonna come back up.
I'm impressed.
I'm not going to touch my phone. I just leave it there.
Oh,
I can also just add them to the Wi-Fi network and then delete them.
Oh yeah, you're in the yeah. Here, I'm gonna present everyone.
That'd be great because we're burning through data.
Okay. So I'm back.
Let me.
So you can come over to mine now. That'll work.
Well, yeah, I would. The only reason why I do it is just in case any cover. But I don't have the guest access to the Wi-Fi. Actually, I messaged someone.
I think I know the password because I usually use it a lot.
yeah, that's
So-
what we are always on, is the guest network.
Do you know how to?
It's CSD Austin or CSD
All
guest.
caps, CSD, and then guest, just the first letters capitalized.
They wanted to stop
And then the
recording.
password is capital C, capital S, capital D, but then Austin is lowercase with an exclamation point. All of Austin.
I'm recording the audio. One minute.
And that's where you log into that Fortinet that comes
Yeah,
up,
Fortinet.
that pop-up comes up.
Okay.
Okay.
You get it? I guess I should write that down for future reference.
So when building a concurrent system, using OTP, we have to decide whether to name the processes so that we can address them. But of course, if we give something a name, that's the only copy we can have of it. So that means we can't do pooling. Because you can't address the individual elements of the pool, you can only address the actual supervisor of the pool that would distribute work. If we want to name a group of processes, such as in a pool, we would like to, give them a number or maybe a letter, but then they have their name. So what we would do instead is we use a process registry like gproc or pg2 so that we can take some property of the pool and then use that as its name. And OTP, seeing that this would be a very obvious use case, allows us to do that with the via option, which allows us to say that instead of sending messages to a fixed atom name or sending it to a PID, we can actually send it to a tuple that describes how to find the process. And the nice thing about this indirection is that can actually distribute it so that the processes can be on multiple different nodes. The process registry just has to know how to find them. And so we're using this process registry. We can start with all the nodes being on the one OS process and then distribute them later. And our actual code doesn't have to change. The only time we would see a change that this would matter is if we noticed that our code didn't handle latency correctly, which really would point out that there was a design flaw in the original code. We just weren't exposing it. When we're using GenServer, there's two class of function call we can do. There's the call, which is synchronous in the sense that it'll block the caller. But in the background, it's still the normal distributed Erlang distributed message passing. So we're sending a message to the process, which might not even be on the same machine, and then waiting for a response. And under the covers, GenServer is being very nice to us, and it's actually setting up a monitor of the remote node and of the remote process. So if the node dies or the process dies, we'll know that we shouldn't expect a response. But this does mean that we can actually get a response, not just from the immediate equal sign of the GenServer call, but if the node actually went down or the process went down, we would actually get a exit message in a normal receive. It'll be in our message queue in the mailbox. So if you really want to handle nodes going down, you actually have to support that also happening the next time you do a receive. Now, this might not matter because you'll set up your receives to only match exit messages from processes you expect to get the messages from. But if you're setting very short timeouts, like, I don't know, under a second, because remember the timeouts are in milliseconds, if you set them very short and your network latency goes very high, you will stop listening for stuff so early that you'll get messages after the fact from those nodes when they finally get around to talking to you. And so your mailbox can just bloat that way.
Because you never process them after that.
Because you as the client thought the timeout happened, but the server is still going to send you the message.
You never slip it out. Okay.
When a supervisor starts his children, they don't start in parallel. They start in the order specified. But if the supervisor has to restart all the children, we might want it to happen quickly. So there's an idiom for getting around the fact that the first child blocks the next child, is that immediately in the init, you can send a message to the process by doing send self to finish the rest of its initialization so that the actual init call returns quickly. But since you did a send self, and before init, no process can know your PID, you can then that first message to say finish your init will be the first thing you process. Because from a process perspective, the message queue is in order. And so since no one knows what you get, any message you send yourself has to be there first. Now the caveat to that is that if you use the name keyword option to name a process so that it's addressable by an atom, that name gets registered before init returns. So someone could actually talk to you before you're actually started, and they could win the race. So what Elixir in Action recommends is on page 193, at the end of section 7.3.2, is in init, you do your fast initialization, you send real init to yourself to finish your initialization that takes too long, and then you register your own name instead of using the name keyword argument. And that way, you don't have a race with whether the person that knows your name can talk to you before you can talk to yourself. So not everything needs to be in a process, but the reasons to be in a process is if you need long-living state, such as a cache. The code handles a resource that we'd like to reuse, which is kind of like caching still. So like a TCP connection. So for a real-world example, RabbitMQ, just like WebSockets, has multiple channels or multiple queues, but they really want you to have one TCP connection because the TCP connection can be expensive to start up because it's going to use SSL and the SSL handshake. It takes a lot of time compared to what you're doing over the channel. So a lot of times you'll want to hold on to that connection to the RabbitMQ broker in one process and have everyone talk through to actually set up the queues. The final reason is you want something that's synchronized. So you have something that you care about ordering, so it has to go through the only way that we have to synchronize code in Erlang, which is one process.
And that's struck me for a long time as it's both awesome because of how cheap concurrency is, but it's also extremely heavyweight. You know, when you think about basically to get a lock on something, right? Now there's a lot more there, but if all you do is use it for synchronization, you're paying like, a K of memory space for just to synchronize something. So it just seems very, very heavyweight as compared to, I don't know, like a Go channel that's just a buffer with, with like one element or however many elements you put on it to first rendezvous.
Yeah, but I think the assumption is that you avoid, because you're always copying your immutable data, you don't have the cycle overhead that a mutex takes to implement on modern CPUs, especially when you're multiple cores away. So you know how modern architecture, the paired cores are cheaper than like the two farther away, and then like if you went 8 cores, each level out it gets more and more expensive because all of the caches have to synchronize for the mutex to actually work. And that overhead is, well, it's up to like thousands of cycles now.
Maybe I thought it was in the same range as accessing RAM. To get another, say, an L2 cache to release memory so that you can write to it. Say it had a read lock.
Well, I didn't think it was as bad as RAM, because that RAM would be another level above like L3 or whatever.
So the last sets I saw, you're looking at L1 cache is like 1 to 2 cycles. L2 cache, this was like an i7 2 years ago.
Okay.
L2 cache was like 8 to 10 clock cycles. L3 was like 80 clock cycles, and RAM was like 200 to 400 clock cycles.
Oh, that's not too bad. I thought it was up to the thousands already. Okay.
No, thousands, like 10,000s. It's SSD or something. So,
okay.
But a atomic compare and swap that forces one L2 cache to release a read lock so that another cache can get a write lock on that block of memory. It will cost you 100 to 200 clock cycles.
Okay.
And it's literally like it's a network on a chip underneath. They're just negotiating, just like you would write it up yourself in software. And that's just all hybrid. So you're saying, I'm sorry, just to follow home on that point, you're suggesting that because of the sheer cost of a simple compare and swap on modern architecture, if you're keeping things effectively single-threaded and you're not moving the memory around.
Well, no, when you are moving the memory, though, you're not actually moving the memory. You're just copying it.
Right.
The problem that happens with cache synchronization is you are actually moving it. You're changing the ownership, and most of the way the beam is implemented, you don't have to do that.
You just do a mem copy. Of that data into someone else.
Yeah, and because it's immutable, you don't have to worry about actually locking the memory page before you do that copy. And so you don't have to do any of the overhead that most of the reasons why you do mutexes and the atomic compare and swap happens. Now, some of that might be actually happening in the part that keeps track of atoms, since that's global, and it might also happen in ETS. I'm not sure how ETS is actually implemented, since that's in C. And that allows multi-reader, multi-writer across processes. But the normal process sending messages stuff, you have the overhead of copying memory, but you also have, then there's no contention because you're copying only. You're copying immutable stuff.
Okay, think about that.
So the talking about pools, the main go-to package for pooling is a package called Poolboy. And Poolboy is actually used inside of Phoenix for the connections.
Inside of Phoenix or Ecto?
Ecto, sorry, you're right, Ecto, yes. Because it just uses Ranch underneath Cowboy for Phoenix itself. So for Phoenix Ecto and Ecto itself, it would use Poolboy, you're right. When deciding whether to use call or cast with GenServer, one of the reasons to use call is when you want to make sure you know it got delivered. A cast doesn't have to reach anyone. It doesn't even have to be listened to. Like there's no feedback that you even got the message wrong, which means that casts while they're very fast because you can send it as a client and move on, means you don't know if you screwed up, and if you screwed up, it is very hard to debug. Like you have to start adding in code to try to read the messages, or use something like Visual Elixir or Observer to try to read the messages going in to figure out where they went. And if you're talking to a remote node, the remote receiver, the EPMD, will just drop the message if you're talking the wrong thing, like if you've got the cookie wrong. So it can be very hard to do a cast and figure out what you're doing wrong. You know that, oh, I just had a typo or something.
How do you figure out what you're doing wrong if it's a call?
For a call, it'll actually fail. So you'll get different error messages back based on how you screwed up.
Okay. So it does basically debugging for you.
Yeah. If I remember correctly, though, it won't tell you that, hey, you got the cookie wrong. It'll just be it couldn't talk to the node.
Oh yeah. It does. Yeah. It just says some like able to connect. Or
Yeah. So it's very cryptic because the EPMD, you know, from a security perspective, can't tell you why you can't authenticate. It's sort of like if you get the cookie wrong and the name wrong, it's just like it is not there, which is the same as the process died. Part of that also is the distributed process theory, where you can't actually tell the difference between a very slow process and a process that has actually died.
Yeah.
Another benefit of using call is that the actual recipient of the call, if it doesn't respond right away, it's a way of doing back pressure, which is very important. Because if the receiver of the call is getting overloaded and it doesn't respond right away, then the client can't issue another request to it. And so that's a way of doing rate limiting that's just kind of built into Gen server call. So that covers chapter 7. Moving on to chapter 8. So fault handling in Elixir and Erlang, unlike a lot of the OO languages we come from, is not just rescuing every exception that can happen. Instead, it's a more thoughtful approach of, is this an error that we can realistically recover from in a useful way, or log in a useful way even? Otherwise, just let OTP's normal error handling take it over and just restart the process. What this handles is weird fault conditions in hardware or on the network that happen so rarely that they're not worth investing the time in handling. That being said, even these faults, if you hook up the tools that are available with the logger, you can log them enough to see if they're happening enough to figure out that, oh, my network card is going bad, and that's what these faults are about. If we do want to care about errors, there are different error types. So there's a try block, just like there is a begin rescue in Ruby, but the try has two ways to capture the errors. There's catch, which is very generic. Catch will capture errors, exits, and throws. So errors are stuff like arithmetic errors when you divide by 0, or undefined function errors when you call a function that doesn't exist, or function clause errors when you call a function with the wrong arguments and they don't match any of them that are defined. Exits are when a process exits and you're monitoring that process, you get notified of that fact. And then throws are, just like Ruby, kind of this weird archaic system of letting you exit out of a deeply nested loop. Now, mind you, loops in Elixir and Erlang are actually recursive function calls because there's no looping construct like there would be in Ruby. So throws are a way of exiting out of this deeply nested area instead of having to handle the return value from exiting partway through the loop. But just like Ruby, you should really avoid throws if you can. because it's frowned upon, but it has to be supported for weird reasons. For a naming convention, most functions with a bang after the name will raise an exception instead of returning the common pattern of OK value, error, reason tuples. There are some caveats, though, where bang might just mean that I'm going to do a dangerous operation. One of the macros does that, where var bang will actually edit the scope it's in, and it'll no longer have hygiene as a macro. But in general, bang means exception. So just like there's a finally clause in in Java, there's an after clause for catch or rescue where you will run this chunk of code whether the error happened or the happy path happened. But since the last thing the try runs is the return value, they've made a design decision that the after block, because cleanup code, will not be the actual return value of the try. The last value of the thing in the try do section or the catch or the rescue section will be the actual return value of the try. This also means that tries can't surround functions that you want to be tail calls because the try itself is the tail call then. So you can't do recursive calls of a function that actually has try inside of it because you'll keep adding stack levels for each of the tries you have.
Is there any way around that?
I think the actual standard library, the way it does it is it'll have a try way at the top. And then it'll loop inside the try using a looping function that doesn't have the try in it. Because you just care that you catch it eventually to like log it or to stop it from impacting the rest of the system. So if you look at the implementation of call in GenServer in the Erlang standard library, it does a try, I think, to catch the node exit message when it monitors the node temporarily while the call is in effect. And so underneath, it's looping on receive. But at the top level, it's going to catch that error, or that exit, I should say. So it kind of falls under, since you can't try recursively, it makes you remember to separate your error handling code from your non-error handling code because it just won't perform well if you combine them. Oh, very important, and if you're running XUnit and you're controlling an outside resource, like a file handle or like a socket, some resource that needs to be cleaned up and that wouldn't get cleaned up normally, you need to make sure in your GenServer or process to do process.flag trap exit true. And what trapping exits will do is that instead of the process just getting the exit message and dying, for GenServer, it'll actually call the terminate2 callback. And that terminate callback is where you can do all your cleanup. So this could be important that if you're using Porcelain or ports to control an external normal OS process, that you'd actually do any cleanup that needs to happen.
So that's what again?
Process.flag trap _ exit, true. So a lot of docs will say trapping exits. That's the actual call you have to make to trap exits. And so I hadn't done that when I was testing my code, and I kept leaving around the Porcelain processes that weren't dying. Because Erlang ports, unfortunately, assumes that the process you're controlling, when standard in closes, it'll die. But a lot of processes don't do that. Like the stuff I was testing was I was actually manipulating the Rails console so that I could test their integration with a Rails app. and it wouldn't die. So I had to make sure in the terminate call to kill it, but my terminate callback was never being called because I forgot to trap exits. Now this is mentioned in the docs a lot, but if you don't do it in your own code, you're totally going to forget that it's important. And you'll wonder why your terminate callback is not being called. So there's two ways to get the exit messages. There are links, which are bidirectional, and there's monitor, which is unidirectional. So if you monitor a process, you get their exit messages, but if you die, they don't hear about you. Links are used in supervision trees because most of the time when the supervisor dies, that means it got so bad that all the other siblings died, and you're going to want to take down the entire tree and restart. Monitoring can be useful for things like caches for processes because you care that the other process died, and so you want to clear it from the cache. Yeah, and so the bit about GenServer call finding out about nodes going down is on page 211 in section 8.2.3 in the gray box. Exits are propagated through GenServer calls, if you want to see the full text. Start link is used as the default interface for a lot of our gen servers, but it's mostly a convention. We can even use it in modules where they're not officially a gen server if we want to emulate that interface. And the reason we do start link is because we want to make it obvious that we're linking to the calling process and that there's not a race condition in the linking. Like there's between spawn and then link versus spawn link. Spawn link gets rid of the race condition that there can happen if the process dies immediately after spawning. It also is possible to directly call start link on the supervisor module that's in the Elixir standard library to set up a supervisor that only exists as a process. If you want to just supervise a bunch of random processes and not set up. I'm not sure when this would be used in production code, but it seems useful for maybe tiny scripts or something. Much like kill-9 in Unix, the actual kill exit message is unavoidable. If you kill, they cannot catch that. Trap exit will not see it, he'll die right away. So that's a great way to kill stuff, but if you kill a process that's controlling an outside resource, you've now just had a resource leak, like you would have in like C or something. So it's not going to leak memory, but you're going to leak whatever's controlling in the outside world. So you have to be very careful about just killing processes in an actual production system. Another reason to allow registered names instead of just PIDs is that a PID is only good as long as that process is alive. But since the supervisor is going to restart the process when it dies, if you have the old PID, it's not going to work anymore. It's just, you're just going to silently send messages to that process and you won't get anything back. So if you have registered names instead, you will always address the process that that name is registered under at that time. So after restart, you can still talk to the same name, which is nice.
The registered name then is a bottleneck. It can be at large scale.
Yes. Yeah, that's why a lot of the, I forget what the code name was for the project in Europe, where they let process groups overlap.
Megacore.
Was it Megacore?
I think so.
Yeah. And that's why Megacore started looking at the overlapping groups, was a way to have process registry when the every node talks to every node gossip protocol doesn't scale anymore.
In other words, reinvent the image. That's what they're going for. That's why we
DNS though is a strict tree though, and the process group thing wasn't. It was like overlapping edge nodes.
No, I
So-
agree. But if you think about how would you implement a registry for processes where you find your way, and Akka has kind of done this to a degree in Scala.
Well, I would actually say it's probably more like border gateway protocol because it's those border nodes
so?
that is how they that's how they describe the implementation is that there's certain nodes that are allowed in two
both.
groups.
Right.
So it's more like border gateway protocol because DNS eventually has like the root servers that know everybody, and it's never meant to work that way. Is my understanding.
Oh, so you wouldn't be able to look up a name globally?
No, that wasn't my understanding.
Okay.
Or if it was, it's almost like the what did Kazaa call it? Like the super users, where like certain users knew about like an entire group of users, but single users had afforded up to those guys.
Right. Yeah, I know. But I mean, if you think about BGP, you still can look up a unique name for every machine on the internet, right? So let's ignore exceptions like private addresses.
Yeah.
Right. I mean, it's done through aggregation tables and routing, right? But there's always a IP address for every single machine on the internet, even though you're using ASs that are cooperating to route through the one system.
Yeah, I'm not sure if it went globally addressing. Maybe it just the traffic has to flow through that node, or they just did. They probably just use hidden nodes to do it because you can have a hidden node that like knows about other nodes, but like they won't know about it, and that stops the gossip protocol from coming back on them.
Mm.
And it's like how you attach Observer or how you attach most of the remote monitoring tools like Xtop to a running production server. Because when Xtop dies or if it crashes, you don't want to take down production, so you attach it as a hidden node. Some of the Elixir SIPs episodes have talked about that, and you always see them using the hidden flag to do that. So I brought this up in the talk before we started covering the book, but the default restart frequency is 5 restarts in 5 seconds. 5 seconds is a huge amount of time in how fast Elixir tests, especially if you do async true and all your tests are run in parallel. You're going to probably run in like 1/10 of a second, unless you're hitting the database a lot. And so it's very easy if you have tests that are actively killing some of your processes that you'll hit the restart limit and start restarting your supervisors. So you have to be very careful about if you're testing how your supervisor restart handling works, that you monitor for hitting this number and that you figure out how to work around it so that it doesn't kill your entire supervision tree, not just the part of the tree under test. So the specifics of the biotuple system is covered in section 9.1.2, starting on page 225. First, when actually doing a start link with GenServer, the name keyword argument, instead of giving an actual atom or alias for the name, you actually do a tuple that starts with the atom via, and then the next element is which module to talk to, and then the final element is the like key you want to use. So for the example they use is they use a key of database worker and then a number. And the reason you do this is atoms, like symbols were in Ruby until 2.3, are global. It's one of the few things that's actually shared in Erlang to allow atoms to be compared quickly. And so you don't actually want to generate an atom of database underscore worker underscore 1, database underscore worker underscore 2, and just do that like dynamically using string to atom. That's a bad thing to do. If you're trying to do that, you instead want to use a process registry where you can use more complex keys. I did think it was interesting. They point out that Erlang standard library actually has a function called phash2, which allows us to do portable hashing that automatically does the modulo arithmetic so that we can fit it in a given range of numbers. So the reason they use it is to choose a worker from 1 to n. They do phash2 of a key, give it the pool size, and then add 1 because I guess it starts at 0 instead of 1. And it's called phash because it's portable hash so that the hashing works the same on all systems regardless of architecture details, like bit width or endianness. And that way, no matter where you run your Erlang code, it'll give you the same hash value. I would assume that's necessary for stuff like consistent hashing and rings, like in React.
Where is phash in chapter 9?
It is in section 9.1.4, removing the database process, in the example code listing 9.7 in the choose worker private function.
Okay.
Yeah, I thought that was very neat that it's a hash function that also does modular arithmetic, so you don't have to do the very common thing of remapping to the range. So going back to the problem of having restarts during tests is there are multiple restart strategies when you're restarting the process. One of them is temporary. So temporary is useful if you are doing something like a socket where if the socket goes away, just kill the process. Like there's nothing you can do. You don't want to reopen the socket because the client was initiating the connection to the server. You just wait for a reconnect and then reestablish from that way. Additionally, something that I hit during testing is I had a on-purpose exit when the queue deleted, and that's a normal exit, but normal exits with the default restart strategy will restart again. What I probably would have wanted, if I wanted to actually have it work that way, would have done restart transient, and what that says is that if you have an exception that causes the restart, then restart. Otherwise, if you just exit normally, shut down. And that can be useful for processes that are doing caching where you want the cache to only live a certain amount of time, like 5 minutes. Oh, the user hasn't touched this in a while, I'll let the process die. And when you let it die, you're going to have it exit normally. And you don't want to restart it because otherwise you didn't actually get rid of that caching process. If you want to do the equivalent of a pool of your own, the strategy you'd use instead of 1-for-1 is simple 1-for-1, which has a weird name. But simple 1-for-1, you only get one child spec. And when you start children, you use the default arguments as the beginning of the argument list, and then you can add on your own arguments to the end. And this way you could dynamically spin up children for that supervisor as your own way to do a pool if something like Pool Boy doesn't work for you. This could be the case if like Pool Boy's customization options are too restrictive or can't encode the sort of logic you want to use, and you don't want a fixed size pool. The implementation of the process registry on page 239, which is section 9.2.1, goes over the equivalent of the double check algorithm for locking. So since sending a message to another process is a distributed action, by the time the message gets there, another message asking for the same action could already be in the mailbox. So say you're trying to cache something and you're going to ask it to actually do the calculation to fill the cache. When it actually processes that message, it might actually be the second time seeing that message, because it will see the first message, populate the queue, and then pick another message out of the mailbox, and it'll say populate, because 2 of them fired while it was making the first cache value. And so you always want to check to see, wait, should I actually do this work? And that helps with idempotence, which is very important. Because for the most part, we can model Erlang messages as being at most once delivery, but for race conditions where we have multiple clients potentially sending these messages like, hey, give me the cache value, or calculate the cache value, we have to do that handling for ourselves and check if we're getting a message more than once. The final restart strategy for supervisors is rest for one. And rest for one is useful if you have like a pipeline or a chain of dependencies. So you can have rest for one with only 2 children, where if the first thing goes down, like the actual cache, then the supervisor of all the things that's being cached should also go down, because without the cache, you can't look up all those processes. They are just anonymous processes. But another use case for this is if you have a chain of processes that are doing transformations, and you have them in parallel because you're kind of doing like parallel streams or something manually, then if any part of the earlier chain breaks down, you want to restart the entire chain, because the pipeline won't be connected anymore. So that's another reason to do rest for one, is that whichever part fails, everything down the line will get restarted with that. And so you'll make sure that the stream is still connected. The one part of Elixir and Erlang code that will look a lot like the error handling rich Java or Ruby code is something called the error kernel. The book actually recommends that in every handle call that is part of your error kernel, the part that can't crash, like say the cache, assuming the cache is important to do lookups and not just saving rendered pages. As is the case here, the process cache is very important because it's the part that tells you how to talk to the different to-do lists. You actually do a try-catch around every state transformation. If it succeeds, then give back the value. If it doesn't, because you have immutable values, you can just give back the values, the state that you started with. So rollback just happens because of immutability. And the actual example is in section 9.3.1. The listing itself doesn't have a number, unfortunately. So when a process crashes, we lose all state, and the supervisor restarts from a known state, and not a state we can change. They're usually fixed values from the child spec. So then you're like, well, if it crashes, I lost all my data. So then you save it in an external data store, like a database. But you have to always be careful that the state you're saving may be the reason why the process crashed. So you have to be very careful when saving state that it's not going to instantly keep killing the process. Now, part of that is if it keeps killing the process, you'll hit the restart count, then the supervisor will die. And hopefully, as you go up the level of supervisors, you'll have more thorough cleanup to say, well, we're going to delist that user. They've done something hinky. We won't touch their data anymore. But if you just keep going up the supervisor and restarting, all you'll do is you'll restart slower and slower, and you'll constantly have these waves of restarts that go up the tree farther and farther. Now, if it happens that someone's not trying to hit you in 5 requests in 5 seconds that kill it, or then 25 requests in 5 seconds that kill the next level up, and so on, then you may never actually see this being a problem, and you'll just have that bad data in there forever until the user actually reports that their system doesn't work. But it's something to be aware of if you're having this cascading failures, that maybe you're persisting state that can get too dirty to work with. And there are lots of tools to actually look at this. The one actually from the Erlang ecosystem that Erlang Solutions has is Wombat. But some of the Ruby tools can do Elixir monitoring now. I think Honeybadger.io can.
Oh, totally.
Yeah. And there's also ways to not use a SAS to do the monitoring that hooks into the OTP system, which some of the Elixir SIPs have talked about. Okay, moving on to chapter 10. So if you have an anonymous function, one of the things to be aware of is that just like everything else that gets sent between processes, is it has to be a complete copy, which means the entire closure of that lambda is a deep copy. So you don't really want to have a lot of local variables with a lot of data sitting there. I'm not even sure if, I'd have to look at the actual implementation to see if the lambda captures the entire local variables or just the ones that it knows the lambda uses. I'm not sure. Now, obviously, if it captures all the local variables, that could be much worse because you might have an entire data structure tree in there. But it's something to be aware of. And that's actually why, I don't remember if it's in here or if it's in one of the other books that actually recommends that if you have to send anonymous functions over the network, don't do it. Instead, what you should do is you should send tuples of the module name and the function name, which you can actually do with spawn. Spawn actually and spawn link actually allows you to send a module name and a function instead of that, and then you'll just send the code over there once and run it, as opposed to sending a lambda which can capture whatever you currently have in local scope.
So send a tuple with module and function. So MFA.
Yeah, MFA. So MFA is module function arguments.
Right.
So it's going to be a 3-tuple of the module name, which will be an atom, or an alias, which is an atom. The function name, which will be another atom, and then an array of arguments. And that MFA argument actually works for the apply function. So MFA is used throughout OTP. MFA is referenced all the time in Gen Server and parts like that.
It's pretty cool how portable code is.
Yeah.
It's just it's not locked down to any particular node.
Yeah. No, I mean that's the most powerful.
Yeah.
And when you think about it, that's what Java was created to do, right? That's why Java serialization is baked so deep into the language, right? Yeah. Which is what you were referencing with turn to binary. Right?
I did find out recently that Java doesn't handle nulls well in the serialization protocol, and they never fixed it because it's a backwards compatibility thing.
I never understood why, if the whole purpose of Java was to be able to throw code portably over the net to set-top boxes or whatever, what they were thinking back in the early 90s, why their serialization sucked so badly. I never got that. Maybe the serialization technology has moved so far in the time since.
Well, when Java came out, Corbo was still an idea, right?
No,
and Corbo was
full-blown.
Right, and Corbo was incredibly complex.
Yes. And not really compatible.
Yeah. Corbo tried to cover everybody's use case, and so it was way too complex to actually implement correctly. Oh, on that note, though, the Erlang Standard library does have Corbo support.
Yes.
I don't know if it's compiled in on Homebrew or not. That is the thing. If you actually want to ship Elixir and Erlang, there's probably a lot of things you can turn off that's in the Homebrew build, or even the Ubuntu builds that Erlang solution gives you. I think they turn off some of the old features, if I remember correctly, in the debs that they ship. So say you get to the bottleneck of the process registry and the caching process are typically bottleneck. You can't talk to a single process anymore. Then the go-to use case isn't let's use Redis, it's let's use ETS. ETS is a special data structure that Beam supports that allows single writer, multiple reader, and multiple reader, multiple writer, and it's handled at the C level of how to coordinate that data so that no one can see weird state. It's kind of an in-memory key value store.
I'm not sure that ETS and Redis are comparable, right? You could use Redis No, that's not a good example.
Well, I agree. So Redis has like all these really neat data structures like Z-sets. That if you're using those, yes, Redis is much better. But if you're using it for I'm going to use it as a cache that a bunch of people can talk to.
Yeah.
Ets is a much lighter way to do that
For shared state.
in an Erlang ecosystem.
The default data structure for shared state.
Yeah.
That's, I kind of think of X as just a non-garbage collected section of memory. You know, I mean, it's like it's like here's your piece of the heap. You need to manage it. You need to control it. It's just like heap out. You know, it's like
But what was that project that's some sort of library to work with X? We're talking about
Amnesia.
Amnesia.
Yeah. So X was created for Amnesia.
Oh, yeah.
And all of that, the biggest advantage of the whole darn thing is it's in process. Right?
We were talking about this.
We were, last year.
So Amnesia is built on top of Ets, and it gives you a little bit more of database features than a normal key value store. So you get transactions that you don't get in Ets. Ets, there's ways to address it where you can make sure that you don't see inconsistent states. So you can be like, I won't see any writes after this point, which I think is usually good enough if you're actually thinking about distributed systems. Or there's actual transactions. So if you want to do, like updates and you want to make sure that the update is consistent with the initial read state, you can do that with Amnesia because you pass an anonymous function to the transaction. That's the only way to actually do transactions with Amnesia is to pass an anonymous function to do work so that it knows that it's doing a consistent operation. I would definitely say if you're considering like SQLite and you're not using something that really needs SQL, like you just want something in memory to store, that Amnesia is probably a good choice.
Yeah.
Now, if you want the on-disk version of SQLite, maybe it's a good idea to use SQLite if you want to be able to read it with normal SQLite tools for debugging purposes. That'd be the one reason I can think to use it.
I'd like to be able to back Amnesia SQLite instead of Guts. Right? And that would be cool.
I don't know if it would actually address the memory correctly.
Well, I mean, if it was easy, it would have been done. I mean, Amnesia's been this warp for
maybe
5-10 years now. No one just felt the need to fix it.
I mean, the people that really use it probably find it good enough, and it could just be that no one's had the expertise in SQLite also to want to do it.
So I think the most common, I think from my understanding, the two most common reasons you would use Ets, Dets, and Amnesia, like I'm trying to take the whole spectrum, right? So we talked about Ets as like, this is a shared state thing. So instead of processes holding the data, you all kind of reach into a heap. Collectively, there's all your old locking issues. You can do various things to manage that, right? Like have a process sit in front of the X table to synchronize, like we talked about earlier. And I think there's an option in X to do some level of locking.
Yeah, I think the default mode is single writer, multiple reader, and then you can open it up to full public where there's multiple writes, but then it's just last write wins, which if you read any of the distributed papers, like last write wins is the worst system.
Well, and also X is like, I think the foremost bottleneck in many systems is X reads and writes.
And also them getting huge. That's eating too much memory is another thing I've heard.
All right. But there's another, I think where you see, so once you outgrow Ets and you need transactions and you need other stuff, where you see Amnesia frequently still be useful is like metadata, right? So a lot of situations with, say, Postgres, you'll see, like Postgres itself, it'll write blobs out to disk as files. It won't even put it in its tables, right? And you can do the same thing. I mean, you can write stuff to disk and just put the metadata that you need in process and you need to be able to access very, very cheaply into an Amnesia database, right? And share that across processes and nodes. And then once you find what you actually want, you go to disk and pull the blob, and work with the binary. So that's my. I'd be interested if anyone says no, Ed, you totally out to lunch.
No, and I've heard the next thing after that, of course, is using React.
Right.
Which React does have the benefit of, if you are actually going to go distributed, it'll handle all the CRDT stuff for you now.
React is RIAK. I don't know if that matters.
Yeah, it does.
The book does recommend that if you go to multi-writer, multi-reader ETS mode, to just have the supervisor monitor it, because ETS requires a process to monitor it, but if the process itself isn't doing any work because of the writers, then you might as well just have a supervisor watch it, because the supervisor shouldn't crash that often. Unless, like I said, you accidentally have all the children restart a lot.
It seems like it's not that hard to put. You can have multiple writer type thing, but to avoid the last writer wins, you have a process whose sole purpose is to play after it. So basically, you use that as your synchronization point, and you basically get a token, so therefore you can write, right? And so you're accessing data directly, but you're saying, hey, can I go in? No, sorry.
And the referee system actually is one of the ways that the books about scaling and distribution cover how to do back pressures.
Right.
Or maybe you have a ticket
Exactly.
system of like, you have 5 tickets to do this, you must give me a ticket. Because the ticket system, as opposed to actually having to look up yourself, like if they don't have a ticket that's signed, it's very fast to check that that ticket is invalid for the time period.
Right.
And have to go through the trouble of like, okay, your client ID is this. Now I have to go talk to this other process to look up what your remaining queue is for this time period, because your time periods are over here on this other machine. And so a ticketing system that, script practically signed with an expiration date the way like JWT would be, is a very easy way to be like, oh no, you're invalid, go away.
Yeah, no, that's a...
And just the fact that since you have to ask for the ticketing system itself is a bottleneck that you like, because it might not be able to respond fast enough to issue tickets, and that's the indication that it should be issuing tickets.
Yeah.
So it's self-regulating that way.
So, and then the other thing, kind of the counterpoint to what you just said, though, is one of the methods to get very high throughput, to cheat the read-write system. We've been using it in caches forever. You have a write-back cache or a write-through cache, right? And so very often you want to write to a journal, but read from, a moderator, a controlled store. And then you let some other process asynchronously, write to the controlled store. And all you do when you go to access stuff is you check the journal, like checking the cache. If you have a more up-to-date thing than what I'm pulling out, no? Okay, I'm good. Otherwise, oh yeah, throw that away, grab this thing that hasn't quite been written into the store yet. And that's how you can, if you put the right structure behind that, that's how you can deal with, the queue problem and back pressure while still maintaining very high throughput.
If I remember correctly, that's actually how the CRDT part of React happened, was not in, I forget where the transition was. I think it was in like 1.6 or something. Like the CRDT used to be exposed to you, and you're like, you have to reconcile. And then they figured out, well, we know the data structure, we can reconcile for you. And so like they have the local cache, and then they have a remote one. And so they're like, if the local one's good enough, we'll just use it. And if we actually know about something else, we'll reconcile for you.
Okay.
Now, mind you, React is like, for it to actually work well, you need it on 3 distinct machines. And so it gets back to that level of you're using an external process with overhead that you don't have with Amnesia. So you have to be very aware of whether you want to use that and whether you're actually taking advantage of it. Because the whole like triple redundancy for failover doesn't work if you're just running 3 OS processes in one box. Like, why do that?
Yeah.
So if you can get away with running it very light and putting the persistent data in Postgres every once in a while, that might be good enough.
Yeah.
So ETS, going back to ETS, can actually get very complex for how we do the queries. And the reason for this is that ETS by default acts like a pseudo process. So it's going to give you back all the data with a deep copy. And so if you want to do complex queries or transformations, you actually have to give your data to the ETS process. But the way it does that is to me, it actually looks like kind of a precursor to Mongo queries. So if you look at like the match specification section,
Mongo, M-O-N-G-O. There's a database called MongoDB.
So in section 10.2.3, it goes over there's actually a parse transform, which is the Erlang equivalent of macros that you can actually turn on so that you give a normal FN style anonymous function, and that actually says how to match your data and how to give back your data, and it spits out this crazy list tuple thing. Now, with that being a parse transform, much like macros, the structure has to be fixed at compile time. So there's limitations to what you can do there. Or you'd have to have a bunch of functions that handle all the different structures you have. You can have a super flexible structure. You need like a fixed number of arguments in fixed position to do that sort of thing. So we already covered the discussion of amnesia and ETS and React relative to Redis, so that covers all my notes. Does anyone have any announcements or anything else that they found during their reading? Okay.
We just covered a ton of that.
Yeah. I kind of blew through, skimmed through these chapters the other night. But didn't have enough time to go through them in depth myself.
Okay, what is everyone working on in their free time on Elixir? Because you're not just doing this book, I assume.
That was the thing I wanted to binge read around.
I'm just trying to finish that this little demo app that Peter and I started working on.
All right, for the training.
The little chat app.
Mhm.
I did work a little bit on it over the holidays. I didn't have a ton of time. It's basically like I'm getting to this point where I'm setting up a gen server and storing like the chat state in there and just kind of doing that bit. But I'm also trying to do it. Basically, what we're trying to do is like set it up like we get the solution and then we take and we have like tests and then we take out various pieces. And so like the example is like an incomplete solution. So that's gone pretty well, but we still have like I think two more lessons we want to do. One is on supervisors and setting one up. So I need to learn more about that. And then I think the last part is just connecting them via the nodes. So then like the final thing would be everyone, takes the final code and then connects up the nodes and you can chat with one node.
Oh, related to connecting nodes, there's, I can't remember which article he covers in Elixir 6, but when you ship like a node in release, there's actually a file called vm.config where you can tell nodes about each other ahead of time. And assuming you have DNS set up so that you can just hard code the name, you can actually have nodes know about each other. Like that's how you can set up the Phoenix PG2 thing so that you can have distributed Phoenix nodes.
Oh.
They just do it by their DNS names?
Yeah, because the long name for Erlang nodes are, some name you make up at their normal DNS name.
Right. They still have to have the shared cookie.
Yes. Yeah, so you put the shared cookie in there too.
Okay.
So you can do that as part of the app config and like how you set up EXRM to do the release management.
Okay.
Oh, I forgot to mention, but I did release IntelliJ Elixir 2.0.0 today. It has support for way more highlighting. So a lot of keywords are highlighted. You can turn on highlighting of standard library stuff from kernel if you want to. It's off by default, but if you go into highlight settings, you can actually have like def and raise and stuff be a different color if you really like that. Also, module attributes, because they're the simplest thing to find because it's just an @ sign and then a name, has all of like the normal IntelliJ features. So you can go to declaration, you can find usage. You can even do inline refactoring where you say to refactor it, you type and it changes all the usages at the same time. In the greater community, Erlang Factory San Francisco is coming up soon. I don't remember when exactly. And then, as we discussed, Elixir 1.2 just came out. A new version of Phoenix came out. I think that covers most of the community news. The big thing about Elixir 1.2, which is very cool, is the with construct. So if you do any error handling where your error handling pattern was, if I get an error, then I have to, all the functions after that point in the pipeline have to accept error and just pass it along. With can get around that because on the first error, on the first non-match, like if you're doing okay, tuples over and over again, the first one that doesn't match will just be the return value of the with. So you can get rid of a lot of your, every function later in the pipeline has to handle the error case stuff.
So sounds like they're. I just downloaded Thomas's update for 1.2 yesterday, so I haven't read into it yet. But it sounds like that's their answer to basically like a nomadic style of coding.
Yeah, it's.
So it's like a case statement, but it's a with statement.
It's not a case statement because the arrows go the other way. So it uses the for style of arrows because it's an assignment arrow. So it's the arrow pointing this way for you. So pointing at the variable you're assigning to,
yeah, so
the way fours are.
It sounds a lot like a B statement in Haskell.
Yeah, a lot of people have said that.
Okay. So do you guys know what I'm talking about at all? All right, so are either of you C or C++ coders? No? Okay. Language you're most comfortable with? All right, so I guess it'd be like locally creating like I'm just. What do you say? That's the first thing.
You don't want to go into like the burrito example for mine.
The thing I like the most, if you're interested, go look up railroad-oriented programming.
Oh yeah, there's an Elixir article on that because it was
Elixir, Elixir railroad-oriented programming, right? It's really cool, and it's a very intuitive way. Like, yeah, that's what I've been doing this whole time.
I would also say that the with is an alternative to the pipe dream library that Bruce Tate made over a year ago, which allowed you to do this sort of thing where you had a pipeline that started with like pipe okay, and then it would only continue while everything was okay. It also handles like other things like pipe until and a bunch of pipe while. So the pipe dream library has more options than with does, but with was added because the okay value or error reason tuple is so common in Erlang and really wants to be enforced in Elixir that you really probably want to do that on your own code. So this kind of enforces that style of it's easiest to do that, so you might as well do it.
So can you use the pipe operator with that?
No, because it won't interrupt partway through. So it's either you list them out. So the main assumption is like you'd with instead of having to deal with the okay or error part. So if you pipe but you get okay value or error reason, your next thing in the pipeline also has to handle the error case and pass it through. So you end up with this function clause that's just like, and I pass it through. So the with statement gets rid of the and I pass it through part.
Right.
So that part railroad programming goes away.
So it was pointed out to me by a Haskell guy with a beer about 2 months ago that if you're using, so the way we think about it, where you basically have a pipeline, the problem, you just raise the exact problem. Like, let's say in step 1 of 10, I get an error. Then I'm going to propagate the error, but I still have to go through all 10 steps, and you just want to get out. You're like, I'm done.
Yeah, so that's
right?
what with handles.
And he said that's not, and I find it really interesting in Erlang and Elixir, which are functional languages, and therefore have map like built into their DNA, he pointed out that when you do a map, even though, like in Haskell's or in Scala, the for yield, the for comprehension, it's really you're like the pipe operator. It's inverting the ordering of things. The syntax versus what's happening. And so what you're I'm gonna try to say. Long story short, you're using that, and when you get that first error, you're done. You're not going to call any more maps. You're out of your sequence.
There actually is reduce until now in enum. I just noticed it, so you can actually do that now.
Okay.
The only thing that there isn't a built-in for, which I've had to use because I want to return all errors from JSON API, is like switching tracks in railroad programming, where it's not like first error. It's like once you get an error, then all you care about is errors. But you still have to call all the other functions in case they give you an error. If they give you a valid result, you're like, oh, whatever. And I don't know if the pipe stream library handles support for that, but right now I've just been doing it on my own.
Okay.
And
So-
I kind of feel like I think there's a monad for that
Yeah,
in Haskell.
there's like a monad for everything.
Yeah. Is it a monad or monoid? I
No,
don't know the
it's-
difference between them.
Yeah, no. You want to think of like a overridable semicolon, right? Like where, like in Ruby, you've got hooks, or at least Rails, you've got hooks everywhere, right? So imagine if you could override the semicolon at the end of each statement and do something right there, right? That's kind of like, people would hate me if I said that, but that's
Right. But
That's
I'm
like-
saying that degree, that sort of power.
Yeah, so if you want to do like an if statement, so you put a set of statements and every one of them is like, hey, the semicolon says, hey, if I get an error, get me out, right? Break, right?
Well, and Facebook just, in the latest version of Haskell, I forget that there's like applicative do, where instead of it being like do until error, it's try to do these all in parallel.
Yes.
So like Haskell can do that where they
Yes.
manipulate what the statements mean.
So I really dumb things down and because I always make things too complex. A monad has a very specific mathematical definition. There's the monad laws. There are 3 laws. It makes it highly compositional. And then you can have all sorts of crazy types of monads. Applicative is a more like a monad is a very specific case. And if you think of it as an overridable semicolon, which is one of many ways to think about it, what that implies is it has to be sequential. You do A, then you do B, then you do C, and you're weaving through whatever you want to do. In the case of OK result versus error, right, you're checking whether there's an error. If there's an OK result, you pull out the result and pass it on to the next thing, right? That's what you're weaving through every statement. If there's an error, you pop out, right? But you can have something entirely different. You could be managing state instead of OK versus error, right?
Related to that, with some of the statements don't have to have the arrow, and then it just becomes like a let statement for the rest of So you can just do a normal equal sign match to do a variable assignment partway through, and it's comma separated. Because you know how like for can get super complicated with like filters and setting up temporary variables? With has that support too. So anytime you use the backwards point arrow, that is going to try to match. But anytime you just do a normal statement on comma separated, it'll just be like normal code, and it'll just set up for the rest of the statements after that point. So if you need to do OK value and then manipulate that value before you call the next function, and you don't want to like embed it in the function call body,
right,
you can do that in a with by having another comma separated statement.
Okay.
I would say with all the commas, it feels way more like Erlang, because we got rid of the commas, and then we're going back to it now.
Hey, for anyone who listens to this afterwards, my description of monads is really horrible, and I'm sorry I ever verbalized it.
The monad
Go on
back to you.
Go on the internet.
Ask the fools to come after you.
They will.
I just keep
The
reading
gods
those
will come
articles
after you.
and try to understand it, but like Haskell articles just have like this type of arrows. You're like, great, those are variables. How did that point out to me that they have properties? I'll eventually get it. Like I read enough closure articles and eventually I could understand their examples.
The key thing you brought up about Facebook and applicative monads basically require you to be sequential. You do A, then you do B, then you do C. But there are certain features of a monad that are more general. And so you can think of like a hierarchy of traits. And so, monad is the most specific. And if you take away something like, you take away that sequentiality, and you just stick with a map function, basically, then you can go parallel.
Right.
Because monads specifically expect that C is dependent on B is dependent on A, if each of those is a statement. And applicative type stuff is seeming a lot more familiar, I think, to anyone programming Elixir, a lot more natural. It doesn't assume dependencies between each of the statements. That was a really bad description. I'm going to stop.
There are a lot of, I can't remember the guy's name, but there's a bunch of answers on Quora explaining like the math behind monads and stuff that are very good. I'll have to find them and add them to the group when I remember what his name is. So related to our next meetup, maybe, hopefully sometime this month or by next month's meeting, we'll have at least either the JSON API or the JSON RPC library we're working on open sourceable. So hopefully I'll be able to talk about that. If it's done early, I might hold an early meeting. But do we want to meet in person? So our interpreters have to be on video anyway, so we could just do a hangout and not meet here, and then we don't have to drive downtown.
I'm fine either way.
I'm fine either way. I get more out of direct comms than
Okay, that's what I figured.
BTC. But
Plus the fact that we can see there's some Elixir people here in town.
and who knows? Someday we may all go out for a beer or something after this.
Yeah, I mean, but I don't know. That's a good question. Maybe billing it as a strictly online meetup might actually get
And
more
try to spread.
attendance.
Well, and assuming I set it up the correct way next time.
Well, because there's like a lot of people that want to participate, but they're like, like tonight, like, oh, it's raining, I don't want to drive.
Oh yeah, once I saw how bad the rain was, I'm like, shit.
Yeah.
I think we should look at. No, I'm saying stuff in the cheap seat. So like, if you need something like help with this, tell me. But we may consider. Are there Elixir meetups in Houston, San Antonio, Dallas? Because a lot of times people see a meetup because their app or whatever says, "Hey, in your vicinity," or because they set 25 miles or whatever.
Oddly enough, I don't think we meet enough or have enough people because a lot of times we don't show up when I search for our own thing. The same thing with the Erlang group. I don't know why.
I only knew about it because I got notified by meetups. So I'm not sure why.
The other
Although,
thing-
if you remember, I did say, "Hey, when did this happen? I didn't see this."
The other thing we could talk about is, like, we're a little weird compared to Dallas. Dallas just has a Beam group. So their LFE and their Erlangers
Everyone hangs
and their
out
Archivist are
together.
all together. And I actually have no problem with that. I guess I would just have to clear it with Jim Freeze if he has really a thing against us joining the Erlang group. Because the guy that runs the Erlang group came to our
Yeah,
meetup.
Tony.
Yeah. And I really have no reason to avoid that. Like, I think we need to understand Erlang anyway. And so I don't see a problem with us going together. Plus, a lot of the Erlang books, like Learn to Use Some Erlang, has chapters that none of the Elixir books cover right now. Because, like, for Dialyzer, like the errors that come on that thing, Learn to Use Some Erlang is like the reference for it. Because the actual docs suck. So us meet up with them. Plus, if they have topics once a month and we have topics once a month, we can meet every other week.
I was going to
And
say, if we
meeting
were-
more works better because when you miss a meeting, it's not a 2-month gap.
Yeah, I agree with that.
Like we missed December because CSD's holiday party was the first Wednesday of the month. Plus, if I remember correctly, CSD hadn't actually approved us being here yet because I had just started working. But
Yeah, I think that would be good. I think too that trying to probably, and I say this because it's something I should work on too, is looking at doing smaller intro talks too, like something shorter that's like, hey, here's a quick code session, or here's something cool in Phoenix, to
Yeah.
kind of cater to other people that are probably like should be focused on like, hey, I'm doing Rails work, but I want to learn how Phoenix can be awesome for my
So I do think the way to that is once we get the two libraries out, you have KRPC so that we can give a talk that's both here and at Austin on Rails because we can talk about both sides of it then.
Yeah.
But I'm looking at, you guys need to come up with something to talk about. Otherwise, it's just me talking and all these things.
I know. Well, it's not. It's definitely on us as attendees, but I still find that I have a hard time getting time together to finish what I even started on that little intro tutorial thing. So that's something I got to finish first. But I agree.
I guess we started figuring out what we're going to do once we clear through the book, which isn't that far away.
Yeah, it's only a chapter to cover. So what, we're at 260, another 80 takes us to 340. Does that finish the book? I think it does. Yeah, it'll finish the book. So yeah, we could have, next month would finish the book, I guess. Let me check if that makes sense chapter-wise. And are people reading or trying to implement everything he's doing?
I'm mostly reading.
Yeah, I mean, that's how I've been doing it. So I feel like it's easier to cover because it's more picking out like the important pieces.
Yeah. Well, guys, should we call this meeting adjourned?
Oh yeah, we do anyway. They're done.
They're done.
Yeah.
After the test. I'm toast.
I don't know
It's
how
kind
you
of
come up with
freezing.
that
I don't
one.
know if it recorded it that way, but it's kind of starting to. It's been doing that for a while.
Yeah, well,
Yeah.
Bit
Well, we'll
choppy.
see.
Yeah, for the first time,
It's a
just kind of
trial
see.
and error.
Yeah, it is.
Yeah.
Absolutely. You may go back and go, "Oh, that's kind of worthless."
Okay.
We'll
We're stopping the
find out.
broadcast now.